We're tackling the problem maximize sum of array after k negations. And we're going to try and solve this with minimum complexities of O n log n time and O n space. In the problem statement, we're given an integer array nums and an integer k, and we need to modify the array in the following way. Choose an index I and replace nums I with negative nums I. You can apply this process k times, and you may choose the same index I multiple times in this process. We need to return the largest possible sum of the array after modifying it in this way. Please note that we need to apply the process exactly k times. So here's some examples that can help us visualize this. In example 1, we can choose index 1. Because we've been given k equals 1, we must apply the process where we multiply the value at an index by negative 1 to create negative nums I, and negative 2 would be the least bad option in this case, if you think about it in terms of we want the maximum sum. In the second example, we can choose index 1 to make this negative into a positive, and then apply the other two k processes to index 2, which is 0 multiplied by negative 1 and 0 multiplied by negative 1. And we'd end up with a total sum of 3 after applying this. And finally, in the final example, we could have a sum of 13 by choosing indices 1 and 4 with k equals 2. As you can see, changing these would give us the maximum sum. Obviously, we wouldn't choose the negative 1 in this case. So I hope that that's helped visualize the problem. So now let's take a look at the 4 possible solutions. Choose the most optimal from A. Divide and conquer, B. Dynamic programming, C. Sorting plus greedy, or D. Priority queue. I'm going to pause for a couple of seconds while you think about the choice. So, for those of you who are able to get it, congratulations. And for those of you who just want to see the code, the answer here is C, sorting plus greedy. Our brute force approach isn't really worth talking about once more. We can try all possible combinations of k negations and calculate the sum for each combination. But as you can see, the time complexity is pretty dreadful. So let's talk about our optimized solution. This uses the combination of sorting and a greedy approach to solve it. By sorting the array in ascending order, we can start from the smallest absolute value element and apply negations to it until we exhaust all k negations, or there are no negative numbers left. This ensures that we prioritize negating the smallest values first, thus maximizing our sum. So, let's take a look at the line by line and see exactly how we can maximize our sum after k negations. So, we start by sorting our nums vector in ascending order. And in this case, we're using the sort function from the algorithm library in C++. We then initialize the variables sum, which stores the running sum of the modified array, and min value, which stores the minimum absolute value encountered. Here it's initialized to int max here, which is the largest integer value in C++. After that, we iterate over the sorted nums vector, and as you can see, if k is non-zero and the current element nums I is negative, we perform a negation by multiplying it by -1, and we decrement k by 1 because we've applied the process once of the k times. Again, within the loop, we update whatever our current minimum value is by taking the minimum between the current element, nums I, and the current min value. So it might be between int max and nums I. After that, we simply add the current element nums I to our sum. After our loop, if k is odd, that indicates that we still have some remaining negations. In that case, we subtract twice the minimum value from the sum to compensate for the negations performed on the smallest absolute value element. Finally, we return the sum as the largest possible sum of the array after applying k negations. And that's it. If you had trouble understanding what's going on, I'd recommend taking a look at the test cases provided using the code and going through it line by line or using the debug mode. You'll see how the variables change as they go through. If you're still struggling with understanding, then you can find some real expert advice from this Udemy course. Dr. Ibrahim is an expert in computer vision and a former competitive programmer, a very good one, and he goes through this problem and about 100 others in his algorithms courses. Part 1 is shown here. In any case, our application is designed to use alongside the course and just focuses on the best method to choose. And for maximize sum of array after k negations, we choose sorting plus greedy. We've got the brief explanation as to why. And if you still need help, our application provides you with some example code in C++, Python, and Java as well. So, if you made it this far, thanks very much for watching the video, and the next Algorithms Pack problem is going to be shortest unsorted continuous subarray.